This meeting is being recorded.
So now let's take a look at if we had a slow initial step in our mechanism. So we're given here the overall reaction. So we see NO2 reacts with carbon monoxide, and then we get our two products over here, NO and CO2 gas. So we're given that the rate law here is this expression where rate equals the constant K times the square of the NO2 concentration. So for this reaction to occur, we also know that carbon monoxide is necessary, but the rate, we're told with this information, does not depend on the concentration of CO. So this would suggest that this reaction must occur in two steps. In the first step, in this proposed mechanism here, we see that we're told that this will be our slow step, and NO2 reacts with another molecule of NO2, and we produce NO3 and NO. And then we see in step 2 here that NO3 can react with CO and yield NO2 and CO2. So what we're looking at here is that the rate for this first elementary step is, we can call it K sub 1 from step 1, it will be NO2 squared, and then the rate here for this fast step. This would not match our rate law, right? Because we see this would look something like this. And this then we must infer is our fast step, because this is not the rate that we observe, or the rate relationship that we observe. It is related here, or the same as what we would expect in step 1. So that's how we know, based on these elementary steps, that this must be a fast step, because these concentrations are not shown in our rate law, or not shown to affect our rate law. So what we also see here is an intermediate. So NO3 is consumed in step 2, and it was produced in step 1. So our intermediate for this reaction would be NO3. And once again, CO, since it's not involved in the slow rate determining step, it would not appear at all in our rate law. And furthermore, we can always assume that if a reaction is elementary, the rate law will be based directly on its molecularity. So that's what we saw above. Now, let's take a look at this example, sample exercise 13 here. If ozone were to react with nitrogen dioxide to produce dinitrogen pentoxide, that is this reaction that we see here. This again is the overall, we'll call that overall reaction. We have a proposed mechanism shown in 2 steps below. So we have step 1 and step 2 here. So what we can infer here from this proposed mechanism is that if the experimental rate law shown is this, we're asked to make some determination about these relative rates from the 2 steps in the mechanism. So we can infer then that step 1 must be our slow step, because that is what our rate law, our experimental rate law, is determined to be. So again, based on that, we would say that step 1 is our slow step, and this is also our rate determining step.